Well, thanks for coming, everyone. So the title of my talk is rather long and involved. Heuristics for interpreting the output of formal panpsychism theories of consciousness. But the content is simpler in that what do we do after we solve consciousness? And what does it mean to solve consciousness? So first of all, there's a big fork in the road. So Dennett and Friston tend to be deflationary about consciousness. That we tend to throw around these words subjectivity and consciousness and stuff, and they want to basically dissolve the confusion by just kind of saying, okay, instead of this consciousness thing, let's talk about brain processing. Let's talk about the algorithms that the brain uses. And let's talk about the cognitive processes which would produce these confusions. And so an historical analogy here is Elan Vital, that we thought life was this vital energy, and then we tried to pin down exactly where this vital energy was, and we couldn't find it. So I see Dennett and Friston as saying consciousness is a lot like this. On the other side, and I am on the other side, Tononi, Tegmark, Penrose, and Hameroff want to discover the formalism. So the idea is that consciousness has this deep formal structure, and to solve consciousness, we want to discover that formal structure. So the historical analogy here would be electromagnetism. There were kind of some odd things like lightning and static and compasses, and Faraday and Maxwell successfully unified these into electromagnetic theory. So there was some sort of deep structure to be found. So I would say that this distinction, this fork in the road, is absolutely fundamental. I call it the real problem of consciousness. And so the goal of consciousness, if you're a formalist, if you think that there is something to be discovered here, is to figure out how to generate a generate a mathematical object that is isomorphic to the system's phenomenology. So this is the goal of IIT and Tononi's lineage. So I would say that there's really surprisingly very little middle ground here. That if we're not formalizing consciousness, or we're not being deflationary about consciousness, or showing why we can explain everything without, bringing this C word in, then what are we doing? And I would suggest that this situation does polarize researchers into, is it something to be explained or explain away? And so as a Qualia formalist myself, I ask myself a lot, by what metric should we evaluate these two options? And I think the healthiest metric, we can talk about it philosophically, metaphysically, until we grow old, but I think it's more productive to judge it by its fruits. That if you can use this assumption that there's some hidden formal structure of reality, and we kind of call parts of that structure consciousness, and then maybe there's some cool, elegant order here to be discovered, then let's assume that's true and try and find it and build cool things. So, secondly, I think the place to start right now, as of 2018, is the interpretation problem. So, let's say orchestrated, integrated prediction reduction 7.0 finally blasts onto the scene and totally solves consciousness. That's awesome. I'd be really excited if that happened. It may not exactly be called that, but we'll see. So then, yay, congratulations. Now what? What do we do with the formal output? How do we figure out what it means? So it would give us this mathematical object that represented someone's phenomenology. We could just plug my brain in, and it would spit out this cool high-dimensional mathematical shape that would represent what it feels like to be me right now. But how do we even begin to understand what that shape would mean? So here's kind of how I break down the problems of consciousness. You have what kind of ontology do you start with? What subset of that ontology counts? How do you draw the boundary of a conscious system? That's an extraordinarily important thing. An IIT and Orch-OR approach it differently. And then kind of more technically mathy type stuff, the topology of information problem. How do you take the information in that boundary and turn it into something that is representative of the structure of phenomenology? And then the state space problem, which is basically, okay, this mathematical object, what kind of object is it? Like, what mathematical space does it live in? What structures does it embody, and so on. But what I want to talk about, I think all those things are fascinating, but today I want to talk about the translation problem, also known as the interpretation problem. That if I gave you a mathematical object which represents what it feels like to be me, what then? So it's extraordinarily important that we don't need to pick a winner. We don't need to say, okay, I believe in IIT, or I believe in Orch-OR, or I believe quantum coherence is critical here. That all we need to do is assume that formalism is the right goal. And so just to give kind of a graphical idea here, so formal theories like IIT would output mathematical objects. And here are some mathematical objects. If IIT output that manifold over there, what would it feel like? What would it feel like to be that manifold? If that represents your phenomenology, I mean, what is that? Would you feel red? Would you feel pain? Would you feel awesome? And so this sounds like a type error, but if we take the idea of formalism seriously, we absolutely have to have answers here. So the existing literature is a little tentative here. So Balduzzi and Tononi talk about the geometry of qualia, and just talking about the different topologies of the different senses. For example, the visual field and the audio field will be somewhat linked, and have kind of a Euclidean character, whereas smell, taste, much less Euclidean. And then Tsuchiya's lab has mentioned that maybe we can apply category theory to this, but they don't necessarily have any strong empirical claims. So I think what a lot of this gets down to are, what are qualia's natural kinds? Where do you start? How do we carve qualia at the joints, as I believe Plato would phrase it? Or if you're a biologist, we can ask, what is the C. elegans of qualia? What is the model organism? The simplest place to start. or the first line of the Rosetta Stone of consciousness? Or just like, what's one true thing that we can say here? And I would have to say that if we take formalism seriously, then math's natural kinds will be Qualia's natural kinds. So what this means is we can kind of list very particularly conceptually interesting things in from a mathematical context, and particularly interesting or salient or elegant things about our phenomenology, and then just try and match them up. So I would say that it's important to look for distinctions in metrics that can be cleanly applied across all cases. And we'll get to that in a little bit. So here's just an example brainstorm. Here you have a bunch of math stuff, and here you have a bunch of phenomenological stuff. We could spend lifetimes just trying to make the connections, and I think there's a lot of interesting stuff here, but I want to zoom in on a specific empirical prediction, which is the symmetry theory of valence. So using this heuristic of like, let's try to find something in the math domain that's interesting and has similar properties to something in the phenomenological domain, we've settled on symmetry as a particularly interesting mathematical property. Likewise, we've settled on emotional valence as a particularly interesting phenomenological property. And we think that anything you say about symmetry in math should also apply to emotional valence in phenomenology. So segueing into just kind of sketching this out a little bit more. So as we saw in the last talk, symmetry is this change without change idea that Wheel noted symmetry, that a thing is symmetrical if there is something you can do to it such that after you've finished doing it, it looks the same as before. And I think the idea that symmetry might be a natural kind in terms of something particularly interesting to look at, physics has benefited enormously from the study of symmetry. And it shows up in hidden ways, but it always shows up. And then symmetry also has some biological significance. Selenafsoy's talk yesterday talked about something that we'll get to. Essentially, we're left with a quandary of, okay, so we want to talk about the symmetry of phenomenology, but what does that mean? How do we like interact with that and neuroscience and biology and the brain? What does this mean? So the empirical framework that we've settled on is that Atasoy's connectome-specific harmonic wave framework, the notion that the brain kind of operates with these connectome-specific harmonics, that the brain's natural eigenvalues are significant for how the brain works, allows a potentially good proxy measure for this symmetry, that harmony in the brain will proxy symmetry in the mathematical representation of phenomenology. And this lets us actually connect with neuroscience. Okay, thanks. So I'm just gonna throw this slide up here. I don't want to explain it in depth, but it's just these are the natural harmonics of the brain, and this is from Atasoy's research. And then if we can figure out a way, and my colleague Andres has pioneered this, if we can figure out a way to evaluate how consonant or dissonant each of these harmonics are with each other, we should be able to sum this up into an emotional state that should be a pretty close proxy for how pleasant or unpleasant it is to be that brain. That's quite the mouthful. If you want more, here's a shortened link to Andres' talk about this. So a bunch of implications here. I think I'm running low on time, so I'm just gonna touch on pleasure centers would thus be pleasure centers by virtue of being tuning knobs for harmony. We should get odd predictions just falling out of this theory, such as tinnitus should lead to affective blunting. This should be, we should be able to literally put somebody in a brain scanner and objectively determine how happy they are, which would be pretty cool. This kind of explains why we seek out pleasure, that symmetry is our brain's success condition. Like that's the gradient that we chase. And in generally, this is a pilot project for using the heuristics listed in part 2 to reverse all sorts of kinds of qualia. So implications for IIT, implications for Orch-OR. But as far as conclusions, just to reiterate the 3 points, formalism is an important frame if you're studying consciousness. And there's very little principled middle ground. There are the formalists and there are the anti-formalists, and it's kind of socially desirable to straddle that, to try and be in the middle, but it may not be completely philosophically defensible. Secondly, interpretation. We don't have to pick a horse to try to reverse engineer the meaning of a formalism. And finally, just if you're interested in the research that we're doing with Atasoy's work and the symmetry theory of valence, get in touch. We're always interested in collaboration. So thank you. Yeah.
6 minutes.
Okay. Question.
Thank you so much for the talk. It's amazing. And I love your statement of the real problem of consciousness. It seems very helpful.
Sure.
So I have 2 questions. One of them is about kind of like a little bit more ultimate thinking about symmetry in general.
Yep.
If I imagine the world sort of starting from an origin and dividing into completely symmetric parts, does that leave space for evolution in terms of differentiating between kind of 2 different conditions and allowing for creation to happen?
Yeah, perfect symmetry is kind of an unstable thing and not all that useful, in that it takes structure to kind of give enough differentiation for complexity to arise. And there's also, in IIT, the more symmetrical the quali is, the less information it can encode, which is a notable thing. Yeah. Yeah.
And so as a quick second question, if you have time.
Yeah.
Why do you think people are not more concerned with quality of valence, as it seems to be kind of a very ultimately important thing, but there doesn't seem to be
right
as much concern as it would warrant?
I think it's a great question. I would say, first of all, people don't see it as a natural kind. They lump emotional valence, the goodness or badness of an experience, in with emotions. And emotions aren't clean natural kinds. But I do think emotional valence is a clean natural kind. So, yeah. Oh, yes?
You talked about mathematical properties in relation to phenomenology.
Mm-hmm.
I was wondering, given how philosophers of mathematics view mathematics itself, you can be fictionalist about mathematics, in which case mathematical entities are like fictional entities, they are not real.
Mm-hmm.
And you can also be conceptualist, like where you can come up with your own figment of imagination about mathematical entities. So in your view, do you think your view presupposes a realist view of mathematics, like along the lines of Plato?
Yeah, it's a good question. I would say that our view, so we kind of assume much the same view of mathematics as physics assumes. So I'm agnostic as to what the exact nature of how to get to the formalism is, but I'm very sympathetic to like dual aspect monism, which would suggest that we kind of inherit the metaphysics of physics. And physics, I think, tends to be fairly mathematical or realist. So that'd be my thought. Yes.
So you're talking about these two legs. What was it, formalists and explaining away?
Yes.
Formalism?
Yes.
Is there another one where you say that it's not possible to formalize?
That would be the explaining away, I think. I think that would be in the explaining away camp.
That's over there?
Yeah, I think it would kind of percolate into that attractor.
Because it sounded like those guys were saying it's not necessary to explain all this stuff.
Right. No need to bring consciousness in.
But I'm suggesting, well, maybe it's not possible to explain it.
Sure.
It's kind of like, it doesn't lead to many grand proposals, I guess. But
Yeah.
it's
Yeah. I would tend to lump that in with the deflationary account,
okay.
but we can talk about that offline. Cool. Yeah.
I was actually going to ask pretty much exactly that question.
Oh, okay.
But I think that third option, I guess in terms of what you guys are doing, you just throw that into the dustbin. That's intractable to us. You might as well be an eliminativist as think, no, there's something big and huge and causally efficacious and mysterious here. It just doesn't lend itself to a formalism. But I think in terms of investigating what's really happening in our universe, then you kind of have to give it its own node, separate from the Dennett's who just think that,
Sure. Well, I would say that ontological and epistemological may be useful to distinguish here, that it's entirely possible that we will never know the formalism just by virtue of our place in the universe. But even if that's true, it is possible that the formalism does exist in some Platonic sense.
What if it doesn't? What if it's just it doesn't behave in a lawful enough way to lend itself to formalism, even if we knew everything about it?
Sure. I think that's a bridge I guess we can see if we have to cross. Yeah. Yeah.
In the realm of symmetry, just wondering how you see the duality in physics and the nature of antimatter and matter. That those seem to be a fundamental part of existence.
Right.
And, but they're symmetries.
Yeah. I would say that they are symmetries, and also they are generated by other symmetries. I think, it just gets, in my mind, it gets to the notion that physics is the study of the symmetry group. Yeah.
So Epicurus said that you got the pleasure-pain axis, and pleasure is the goal of the universe, where pain is sought to be experienced if it leads to a greater pleasure. So if high valence is high symmetry and things, would you have to experience the asymmetrical to reach a higher symmetry?
Right. So that's a good question.
Or is it symmetrical all the way because of the intention going into it?
So there are two forms of knowledge about mental phenomenon. There are kind of contingent facts about how our brain works. And I think the fact that often pain and pleasure, like you have to go through bad times to get to good times and so on, I think that's an evolved adaptive thing.
Okay.
And then there are kind of universal principles that would apply to any conscious system, be they humans or dogs or dinosaurs or aliens. Yeah.
We're technically at the end.
Yep.
You want to take a quick question, or?
I think, yeah.
Can you make it quick?
Yeah, just quickly, I'm troubled by your notion of formalism. I just want to make sure I understand.
Sure.
It seems to me there is a third way, that's where most people are.
Sure.
Are you saying it's just math all the way down? I mean, I would say you don't understand, you're saying physics is symmetry proofs. I would say, no, the math in physics can be described using that.
Sure.
But you don't understand physics unless you're in the world and you understand the reference of the referential terms at the bottom of the physics, right? You don't understand economics until you understand, the referential terms that are at the bottom. And similarly, I would say a theory of consciousness isn't going to be math all the way down. It's going to have these referential terms in it. And that's going to be the ground floor, and you have to understand what those refer to. And that's not math, right? The math describes the structure.
I think I'm taking a more inclusive view of math. Do you have any terms in mind that you think should be accounted for?
I can't think of a good example, but I mean, surely there's a bit of math that we use in physics and then we use it in economics, right? Do I understand this new phenomenon, physical economics? No. What matters is that I know what a good is over here on the economic side. I know what the earth is, or whatever the referential term is over here on the physics side. It's the structure does not tell me this is economics. This is about the mind. This is about, right? I need at the ground floor. There's going to be referential terms.
Sure. Well, I think there is some kind of tug-of-war in metaphysics between kind of empiricism and idealism here, and I may be taking the idealist position.
All right. Thank you.
Yeah.